Good evening. So this session, TSD3, is going to be more about relative speed and trains. So we'll cover theory for both and then we'll go for problem solving. Let us start. In terms of theory, there are straightforward formulas. I'll derive those for you as well. I'll cover 2-3 cases here for derivation. When two people are traveling in same direction, there are two possibilities. First one, there are two people standing at the same point. Let us call the point A. One of the people is named as Ramesh, another one named as Suresh. Speed of the first one, let us assume, is 5 meters per second. And second person, the speed, let us say, is 8 meters per second. Right now, they are at the same point. So the distance between both Ramesh and Suresh is 0. Right now, they have not started traveling. Time is also 0. If I give 1 second time to both of them, that is 1 second each, Ramesh would have covered 5 meters, Suresh would have covered 8 meters. So what is the gap created? The gap created is 3 meters. If I wait for 1 more second, Suresh will travel further 8 meters and Ramesh will further travel 5 meters. 5 meters for Ramesh. So what is the gap created? Ramesh has traveled 10, Suresh has traveled 16. So in total 2 seconds, the gap is 6 meters. If I wait 1 more second, Ramesh will again travel 5 meters and Suresh will travel 8. Now you can see a clear pattern. With every passing second, so what is the total distance of this fellow? 24. This fellow total distance is 15. 24 minus 15, 9 meters. The gap created is 9 meters in 3 seconds. So what I'm trying to teach you here is, if you only are interested in the gap among them, see the gap among them is 3 times of the time period. Where is that 3 coming from? That is called speed relative. When two people go in same direction, it appears to be speed of faster minus speed of slower person. When people go in same direction, speeds are subtracted. This is called distance relative. Distance relative, that is a gap between them, can be written as speed relative into time. Observe, the time has to be same for both. Objects must be moving together. There is no relative time. Time has to be same. These are not relative concept of concept relativity given by Einstein. These are Newton's relative concepts. Here, the gap between them depends upon how much time they have traveled and what is the gap in their speeds. See, I don't want to locate Ramesh and Suresh where they are. I want to know, when can the gap be 120 meters? So you want the gap to be 120 meters. What is the speed gap? 3. You want to know what time will it take? It will take you 40 seconds to achieve that. Please observe. Please observe. I'm dividing it by 3 for that to go there. So it does not matter where they are individually. That is the benefit of speed relative sentence and understanding. In same direction, speeds are subtracted. Write it down somewhere. In same direction, speeds are subtracted. If I ask you, after how much time will Suresh have a lead of? Suresh have a lead of 210 meters after how much time? So after 70 seconds, he will have a lead of 210 meters. This is the concept of relative speed. Their individual positions do not matter. You don't have to find whether individually. You can find out what is the gap between them through relative speed. In same direction, speeds are subtracted. Jot it down, comment done. Yes, there seems to be a bandwidth problem. Sure, let us see the next one. Now I want to apply similar thought process in a case. In this case, there is one more way to look at it. Listen to this. We don't suggest this approach for you to apply in the exam. Suresh has a speed of 8 meters per second. Ramesh has a speed of 5 meters per second. What is the gap between the speeds? 3. So you imagine the speed of the slower one is 0 and the gap is 3. You assign the gap to faster one. Now you can simply imagine relatively this person is stationary, this person is moving forward by 3. This is called leading speed. The faster person is leading the way, leading with the speed of 3 meters per second. Leading with the speed of 3 meters per second. A way to look at the same approach, same question. In this case, imagine Suresh is trying to catch up Ramesh. The gap between both is, let us say, 90 meters. Speed is 8 meters per second and the speed, let us say, is 5 meters per second. So what will happen is with every passing second, this person will travel 555 meters. And the other fellow, Suresh, with every passing second will travel 888. So you see, Suresh is traveling more, 3 meters every second. That means Suresh is getting closer by 3 meters in every second. How much do I want Suresh to get closer to Ramesh by? If I want Suresh to catch Ramesh, I want him to get closer by 90 meters. So listen to the language. Again, in the same direction, the relative speed is equal to faster minus slower. Basically, you are saying the gap between them is 90 and Suresh is closing the gap. Suresh is closing the gap by 3 meters per second. How much time will he take? He will take 30 seconds to catch. This is called chasing speed. You can again imagine like this. The slower one has a speed 0 and faster one has a speed 3. It will give you the same output because the question is when will the overtake happen? When does the overtake happen? You will have the same answer. confirmation on this? This is 70 seconds. This is 40 seconds. That. So simple concept. In same direction, speeds are subtracted. That's all. Speeds are subtracted in same direction. Now, what happens when people travel in opposite direction? If I have a point, common point here, let us call that point A. One person is Ramesh, another person Suresh, very simple names. Ramesh is going right with the speed of 5 meters per second, and Suresh is going left with the speed of, let us say, 8 meters per second. Same observation. The distance between Ramesh Suresh is 0. They have not traveled yet. If I give 1 second to each of them, this one goes 5 meters right, this one goes 8 meters left. So how much is the gap between them? The gap between them is 13. If I wait for total 2 seconds, 5 meters further, 8 meters further. So the gap becomes 10 and 16, 26. If I wait for 3 seconds, you get the idea. 5 seconds further, you can visualize the gap is increasing. That is 39 meters. So what I notice here is the gap between them is 13 times of time. What is this 13? This is called speed relative, the effective speed. Because people are going in opposite direction, we say faster plus slower. Speed gets added. In opposite direction, journey is in opposite direction, speed is increased. Imagine you and your friend are approaching each other on vehicles, on bikes or on cars. You'll feel the other person is traveling faster than usual. So in opposite direction, speeds appear to be higher. The speeds are added. If I want to create a question like this, after how much time will the gap among them be 165 meters? I don't even know if it is multiple of 13 or not. No, it is not a multiple of 13. So when will this gap happen? You want the gap to be 165. They are moving apart by 13. The time t will be 165 by 13 seconds. Simple, simple. What is the concept? Distance relative is equal to speed relative into time. Time cannot be relative. Time must be same. Keep that in mind. The time must be same for both individuals. Time can never be relative. As a concept, these are very simple concepts, nothing heavy, nothing fancy. In this case, they are moving apart with the speed of 13. If I was to imagine they are at the opposite ends of a racetrack, Ramesh is moving right side with the speed of 5 meters per second. Suresh is moving left side with the speed of 8 meters per second. And let us say the gap among them is 299 meters. When will they meet? So it makes me feel they are getting closer to each other. They are coming close to each other with the speed of 299 with the speed of 13 meter per second. Speed relative is 13 meters per second. Opposite direction, you must add speeds. So they are getting closer by speed of 13. When will they meet? So we are saying they have to travel together. Together they have to travel 299 meters with the speed of 13. How much time will they take? So cancel 2 times it is 26, 39 is 3 times gone. So in 23 seconds, they will meet in this much time. Time of meeting is 23 seconds. You want to answer how much have they traveled? You want to know how much has this person traveled? It will be 23 into 5. You want to know how much has this person traveled? 23 into 8. Relative speed, we are using it to answer the time of meet. How much time will it take for them to meet? Opposite direction, speeds are added. You can call this crossing speed. They are crossing each other at a speed of 5 and 8, that is 30 meters per second. Confirmation on this. Now about trains, it will hardly take 10 more minutes. Let us complete all the theory in one go. Now, if you imagine there is a road, a straight road, and there are two people. Let us say this is person A and this is person B. They are racing. They are racing. Two people are racing. The moment that both A and B are on the same, I'll say in the same line, we say the overtake has happened. Overtake has happened. But if A was not riding a bike or a car, but A was a train. Now trains have a length of 100 meters, 200 meters, 300 meters. So in that case, the length of the object starts to matter. Bikes and cars are considered as point objects as compared to a road, as compared to each other. So as soon as they reach the same level as each other, we say overtake is done. Overtake has happened. But when trains are crossing bridges, when cars are crossing trains, when cars are crossing platforms or bridges, the length of one of the or both of the entities will matter. So here let us create a small example. This is a train. Again, don't go too much into formulas. Observe the train has a length of 300 meters. There is a pole. There's a pole. A pole is supposed to be stationary. Now, whether you measure here or you measure here or you measure here, because it is a single object, the speed of every point will be same. If let us say speed of train is, let us say 5 meters per second. When will the train cross the pole? So we imagine this end has to cross the pole. For the train to cross, this end with a cross has to cross the pole. So what is the gap between them? 300 meters. At what speed is the point moving? 5 meters per second. So how long will the train take to cross the pole? 300 by 5. So in this case, only the length of the train matters because pole is supposed to be a point, and also pole is a vertical object. So there is no width related or length that matters here. Only the length of the train matters. If the train cross let us say platform, train has 300 meters, let us say length, and the platform has 200 meters length. Let us assume that. Let us imagine that. Now this corner of the train will have to cross this corner so that we can say crossing has happened. So this corner has to travel how long? This corner has to travel the complete length 500 meters. If I again imagine the speed is, let us say, 10 meters per second. So distance of 500 at the speed of 10, how much time will it take us? It will take 50 seconds for the train to cross the platform. So don't create formulas LA plus LB upon SASB. Don't do that. You visualize the train has to cross the entire platform. So length of the platform will matter. In question, they will tell you a train of length 300 meters is trying to cross a platform of length 200 meters. Never imagine like this. Never imagine that the train and the platform are or have same starting point. Never imagine that. Should always be starting point of one and end point of other should be imagined in this manner. Length must be added. किंतु बोलेगा सवाल में the train is about to leave a platform and so on, so on, so on. If the train is about to leave a platform, you can imagine like this. The train is about to leave the platform. Otherwise, always complete length or both lengths should be considered. Both lengths or complete length should be considered. What if the other object is also moving or starts to move? Again, today is the first sheet of relative speed, so comparatively simpler questions have been kept here. What if both objects start to move? See what happens if there's a train of length 300 meter, there's a bike which is moving at a speed of 5 meters per second, and train speed is, let us say, 10 meters per second. There are two possibilities. Maybe train is trying to overtake the bike, or they are going in opposite directions to each other. So if they are going in same direction, 300 is equal to 10 minus 5 into t, that is speed relative, same directions. If they are going opposite to each other, 300 is equal to 10 plus 5 into t. Don't mug up formulas. Observe, that is speed relative, opposite directions. What if there was another train? You are saying one train is trying to cross another train. One train is trying to cross another train or overtake another train. 300 meters, 200 meters, speed 5 meters per second, speed 10 meters per second. If they are going to cross each other, I'll say 500 meters with a total speed of 15. That is opposite direction. If the faster train is trying to overtake, so I can say 500 meters with a effective speed of this. That is same direction. So you don't have to mug up, visualize. You can simply say use relative speed, opposite direction add speeds, same direction subtract speed. That's all. Length will always be added. Length will always be added. Take your time, jot down some of this. Let me know once you are done. Now, when people start from same position, if I say this is A, this is B, let us again name them Ramesh and Suresh. Suresh is the faster one. Ramesh is traveling. Suresh has already completed and has to turn back to meet. So in that case, how can I use relative speed? I don't actually use relative speed when people have to return to meet the other person. Like let us say Ramesh has a speed of, distance is not known, distance is unknown, some distance between AB. Ramesh has a speed of 3 meters per second. Suresh, let us say, has a speed of 5 meters per second. And or let us say, let me use a decimal value, let us say 8 meters per second. Deliberately using 8 meters per second. So at what distance from A will they meet? It will be 2 by 3 of total distance, 1 by 5 from A. From A. So I don't usually use relative speed in this kind of approach. I say they have together traveled 2D. They have together traveled 2D. And what is the speed ratio of Ramesh and Suresh? Speed ratio is 3 by 8. Learning to decimals. So how far from A are they? This is the distance from A. That is, I need journey of Ramesh. Ramesh is traveling 3 parts out of 11 in 2D. So Ramesh is traveling 6 by 11D. That is distance from A. A lot of people, what they do is they first find out कितनी देर में इधर पहुंचेगा. फिर where is Ramesh, and then वापस opposite direction में they are traveling. क्यों time waste कर रहे हो ये सब करने में? When one person has to return and meet the other person, solve it like this. I've solved maybe 3 questions of this kind in the last session. Last lecture, I've covered 3 questions like this for you. Together, they have traveled 2 distance. moving on. So take your time, take 2 minutes and try. Moving on here, A and B, A and B can cover distance xy in 24 and 16 hours respectively. Hours. Both of them start from opposite ends of xy towards each other. At what time will they meet if they start their journey at 8 a.m.? At what time will they meet? (9.6). What is that? To convert that in the exact meeting time. All right, let me solve. Got an answer? Not meeting time. At what time will they meet? 5:36, 9:30, 5:36 p.m., 5:45, 4:30. All right, all right, all right. Option A. All right. So now observe. There are two standard ways to solve this. One is equations approach. Other is assumption method. So here, if you notice, they are both starting at what? 8 a.m. 8 a.m. So I can say total distance being d, speed of A is d upon 24. Speed of B is d upon 16. Opposite direction when people travel, the total distance must be divided by the addition of speeds. So the time of meeting would be d divided by d by 24, d by 16. I can rearrange this. I can take this d common. This is 16 plus 24 upon 16 into 24. It goes above 24 into 16 upon 40. D will get cancelled. That is the time. So some calculations are required. 4 into 6, 4 into 10, 2 into 8, 2 into 5. You have what? You have 48 upon 5, which is 9.3 by 5. This is hours. You multiply 60, it will become minutes. So 9 hours and 36 minutes. This is a very simple and a very straightforward approach. For that, I had to create equations. Now I want you to notice this part. D is getting cancelled. The value of distance does not matter. If value of distance does not matter, why should I not assume a good number? LCM of both numbers is 48. If I assume the distance is 48, what is the speed of the first vehicle? 48 by 24, the speed is 2. Speed of second vehicle, 48 by 16, speed is 3. So if I imagine or if I assume a distance, it becomes easier for me to solve. In fact, I get answer in 2 steps. 9 hours and 36 minutes. So 9 hours from 8 a.m., 4 hours is 12 noon, and 5 o'clock and 36 minutes. Assumption, how to assume that? You take LCM of speeds and imagine this as distance. Notice I've kept both methods side by side for you to compare. Second method is very effective, very fast. Somebody solved the question by first approach couple of times, several times, then notice that distance is always getting cancelled. That is how these methods are created. Done. Moving on. Now let me recreate same question. Let me recreate same question. X and A and B can cover the distance between X and Y in 24 hours and 16 hours respectively. If A starts at 8 a.m. and B starts at, let us say, 12 noon, at what time will they meet? I have just now created a new question for you. Give it a try. A starts at 8 a.m. and B starts at noon. Exactly at noon, 12 o'clock. Same value. A can cover in 24 hours, B can cover in 16 hours. A starts at 8 a.m. and B starts at noon. Go on, try. In the new question, the time to start is not the same. So in this case, you cannot apply relative speed concept. Yes, you will have to work with that information. But again, I'm saying the value of distance does not matter. अगर ये आपको solve करना है effectively, you want to solve this effectively, the best way is, again you imagine LCM of 24 and 16 as 48. Imagine 48 kilometers are there. So speed of A is 2 kmph. Speed of B is 3 kmph. This one starts at 8 a.m. This one starts at 12 noon. So what you do is, when the other person is starting, B from Y, that is 12 o'clock. Where is this fellow? Kidhar hai ye aadmi? This person has already started 8 a.m. So 2 ka speed into 4 hours. So he has already traveled 8 kilometers. Out of what? Out of 48 kilometers he has already traveled. So what is the gap between them? The gap between them is 40 kilometers. Now they are coming closer to each other with the speed of 5. So 40 kilometer by 5, it will take them exactly 8 hours. So 8 hours from 12 is 8 p.m. they will meet at. Precisely at 8 p.m. they will meet at. The value of the distance does not matter even now. अभी भी distance का value matter नहीं करेगा. I can show you if there are 10 questions in TSD of this kind, the value of distance will not matter. Even if they want you to find out distance, don't create equations, go through options. Because distance can be seen on the screen, you can easily verify the value rather than solving for it. D का variable मत assume करो, take 48, take LCM as the distance. Very easy question, very easy question. Try. A train traveling at 36 kilometers per hour crosses a platform in 60 seconds and a man standing on the platform in 18 seconds. What is the length of the platform in meters? You can answer this in 60 seconds if you are good with observations. So here, first thing, information of time is in seconds and we want platform in meters. So you must convert 36 into 10 meters per second. When a train crosses a person, only the length of the train matters. With 10 meters per second, the train crosses a man in 18 seconds. So this must be speed into time. 180 meters is what? It is the length of train. When the train crosses a platform, the length of both matter. Both lengths matter. So here in 60 seconds with the speed of 10, the total distance traveled is 600 meters. That must be train plus platform. Train is already 180 meters long. Platform must be 420 meters long. So if you apply common sense and observation, no equations are needed, no representation of any other kind is needed. Simply, when a train crosses a man, only train's length will matter. So 18 seconds are required to travel the distance which is equivalent to train length, 180 meters. Now, when train crosses the platform, the length of both will matter. Both means what? The man and the train and the platform. So 60 seconds into 10, 600 meters is train plus platform. Train we already know 180, platform 420 meters, none of these. You can do this pretty much verbally. Again, same question, let's move on. Give it a try. Give this one a try. A man saw a train over a 8-kilometer long bridge. The length of the train is 1/4 that of the bridge. If it clears the bridge in 2.5 minutes, what is the speed of the train? A man saw a train cross over 8 kilometer long bridge. Length of the train is one fourth of the bridge. So again, observation. What is the length of the train? It is one fourth of the bridge. What is one fourth of this? 2. So 10 kilometers bridge and the train. 10 kilometers were crossed in 2.5 minutes. So can I say in 1 minute, 4 kilometers were crossed. In 60 minutes, 240 kilometers were crossed. 60 minutes is 1 hour. What is speed of the train? 240 kmph. So again, we are so comfortable with formulas, we don't apply common sense, observation. Use those faculties here, the faculty of common sense and observation. You will get your answer pretty fast. Moving on. Again, a train crossing a platform, similar question. Try this. Try this. Add one more option. E. None of these. Try. Two trains start from P and Q and head towards Q and P respectively. Train P starts at 8 p.m., reaches Q at 2 p.m. next day. Train Q starts at 7 p.m. same day, on which the train starts from P and reaches P at 3 a.m. next day. At what time approximate will they cross each other? At what time approximate will they cross each other? So please notice distance is not known to you. The individual speeds of trains are not known to you. What you know is when will or how much time will an individual train take to cross. That is the only hint given to you. So please observe. The locations are named P and Q. I'm calling them trains T1 and T2. The train T1 starts at 8 a.m. and finishes journey 2 p.m. next day. Next day. And the train from Q, that is train T2, starts at 7 p.m. This is 8 p.m. This is 8 p.m. This is 7 p.m. Same day as the train from P starts and finishes journey when 3 a.m. So in this case, directly we have given you the amount of time taken. So 8 p.m. to 8 a.m. it's 12 hours. 8 a.m. to 8 p.m. to 8 a.m. 12 hours. So from there plus 4 hours to 12 noon plus 2 hours. So 18 hours are the time taken by first train. 7 p.m. to 12 o'clock night, 5 hours, 5 plus 3, 8 hours. Time taken by the train 2 are 8 hours. So you again immediately calculate LCM. What is the LCM of these numbers? 72. I'm visualizing the distance is 72 kilometers among the 2 points. What is speed of this train? 4 kmph. What is speed of this train? According to the assumption, distance upon speed. 72 upon 8. 9 kmph is the speed of this train. When is the train starting? 8 p.m. When is the train starting? 7 p.m. So this one starts early by 1 hour. So in 1 hour, it will be 9 kilometers ahead. Now they are both moving towards each other. They have a gap of 63 kilometers between them, and together their speed is 13. A gap of 63 with a speed of 13, what time will it take us? 63 by 13. 4 times is 52. Remaining is 11 by 13. Please understand, this is in hours. I need to convert this in minutes. कैसे convert करते हैं minutes में? Into 60 लगा के. So 4 hours are gone from 8 o'clock. And then what is this? This is 660 by 13. 5 times it is 65, बच गया 10. 10 upon 13 is almost 1. Almost 1. 4 घंटे 51 मिनट. After 8 p.m. 8 p.m. it is 4 hours and 51 minutes. So when will they cross each other? They will cross each other at a time of 0051 a.m. ऑब्जर्व, ये कौन सा टाइम है? आफ्टर 8 पीएम का टाइम है. 4 घंटे आफ्टर 8 पीएम. आफ्टर 8 पीएम 4 घंटे मीन्स रात के 12 बजे. 00 आवर्स. मूविंग ऑन. उसको मिनट में कन्वर्ट करना पड़ेगा आपको. you'll have to convert it in minutes. It will be 50.8 minutes. 0.8 minutes क्या ही होता है? 51 minutes आंसर आ जाएगा आपका. Try. Give it a try. A bird is sitting on top of a wall, spots a train which is 900 kilometers away from the wall at a speed of 20 meters per second. The bird starts flying towards the train, reaches the train, and immediately flies back to the wall and again back to the train. This continues till the train collides in the wall. What is the distance covered by bird in kilometers while flying towards the train if the bird flies at a constant speed of 50 meters per second? This is a very, very ancient question. We cover this we cover this question to help people understand how to deal with infinite repetitions. See, visualize this is the land, or railway track. There is a train somewhere here, there's a train somewhere here. This is the wall. This wall has a bird on the top of it. Now, when the bird sees the train, it is 900 kilometers away. Now, what happens is the bird goes towards the train. The train is also moving. So, bird will meet train somewhere on the midway, somewhere on the way, and it immediately flies back. It immediately flies back. So, do you understand? For the bird, starting point is same as the ending point. That means going forward and going backwards. It is traveling same amount of distance. At what speed is the train traveling? 20 meters per second. At what speed is the bird able to fly? 50 meters per second. Now here you need to understand the bird will continue to fly until the train collides in the wall. The train reaches the wall. So let me focus on the train first. The train will have to travel 900 kilometers with a speed of 20 meters per second. Notice here, I have not changed the unit of speed. This is the amount of time. Whether this time is in minutes, days, hours, don't worry. What is it? Don't worry. This is the time needed for the train to reach the wall. Up to this amount of time, the bird continues to fly at what speed? 50. So if I multiply time with this 50 meters per second, 50 meters per second, that is the distance traveled by the bird total while flying towards the train, also while flying backwards. Total distance is this much. Don't multiply by it. Don't multiply. What is the question? How much has been traveled towards the train? Towards the train will be half of the bird's distance. So my answer would look like 900 into 50 upon 20 into 1 by 2. Units will get cancelled by default. The question has been created deliberately in such a manner that people will struggle with units. So this is denominator 4. 4 is cancelled 2 times 8 carried over 1, 2 times 8 carried over 2, 5 times. 225 into 5, that is 10 or 1125. That is 1125 kilometers are traveled towards the train. 1125 kilometers. See, 900 upon 20 is the amount of time train will take to reach the wall. 900 upon 20 is the amount of time train will take to reach the wall. Throughout that time, it could be any 10 hours, 20 hours, 30 hours, whatever that time is, the bird keeps on flying at the speed of 50. So that much time into 50 is the total distance traveled by the bird. Total distance traveled by the bird divided by 2 is the distance traveled in any one direction. Either you take it as towards the train or you take it as away from the train. You don't have to find out when will they meet, at what time will they meet, we don't care. The bird continues to fly till the train reaches the end point. That's all. So you see, I'm waiting till the last step to multiply and divide. Again, if you start converting everything into its proper units in the beginning, time ज़्यादा लगेगा आपको. Multiplication division has to happen at the end. In this case, because the starting and ending point is stationary, so distance will always be half. Give it a try. At an unknown time, a thief broke away from a jail cell. The guard noticed the thief missing from the cell at 11:30 p.m. If the thief had constantly been running in one direction at 60 kmph, the guard immediately starts going after the thief in same direction at speed of 80 kmph, catches the thief at 3 a.m. At what time did the thief break away? At what time did the thief break away? So in this case, let me approach this through relative speed first. I do not know when has thief broken away, but when does the guard realize this? At 11:30. Thief has been running at what speed? 80 kmph. At what speed is the guard starting to chase? 80 kmph. So imagine it is 11:30. It is 11:30 precise. This is the guard. This is the thief. Thief is running away at 60 kmph. The guard is trying to catch at 80 kmph. I do not know what is the distance between them. I do not know, because I do not know when did the thief leave the or got free from the jail or broke free from the jail. I do not know. So now they both are running at 11:30. The guard is trying to chase, thief is trying to run away. When does the catch up happen? The catch up or the catching happens at 3 a.m. So it is 11:30 to 3. It is 3.5 hours. So in 3.5 hours, how much distance can the guard catch up? The guard is catching up with 20 kilometers per hour. 20 kilometers per hour. So in 3.5 kilometers, the guard will catch up 70 kilometers. That means thief has managed to create a gap of 70 kilometers between him and the guard. Thief, language पे ध्यान देना. Thief has managed to create a gap of 70 kilometers between the guard and himself. 60 kmph is the best speed to handle. It basically means 1 kilometer for 1 minute. If I want there to be a gap of 70 kilometers, I will need 70 minutes. That means 70 minutes before 11:30, the thief broke out. Can I say 60 minutes would mean 10:30, 10:30, 10 minutes further would mean 10:20. At 10:20 p.m., the thief broke out. Please observe, it is such a simple and straightforward approach. We have talked about this when the faster person is trying to catch up a slower person. We say distance relative is equal to speed relative into time. Here, what is the speed relative? 20 kilometers is the speed relative. What is the time taken to catch? 3.5 hours. So 3.5 hours into 20, 70 kilometers have been caught up. 70 kilometers was the gap between them. So if the thief started running at a speed of 60 kmph from the beginning, from the start, that would imply 70 minutes earlier he broke out. What is 70 minutes earlier than 11:30? It will be 10:20 p.m. Is there any other way to solve this? Yes. 10:20 is the time. Remember that. Keep that in mind. See, they means the thief and the guard, they are at the same point. The thief starts to run early and then the guard goes after him to catch. For thief and guard to be able to meet, the distance must be same for both. If the distance traveled is not the same, the guard will never be able to catch up the thief. Now please observe, from 11:30 to 3 o'clock is 3.5 hours. 3.5 hours, the guard runs constantly at the speed of 80. So I have found out what is the distance traveled total. Now this distance has to be traveled by thief in some amount of time. So if I cancel 20 into 3, 20 into 4, what I have for you here is 14 upon 3. 14 upon 3 means 4 hours. 4 hours, and then 2 by 3 further. 2 by 3 further is how many minutes? It is 20 into this 40 minutes. So you must observe, understand, a thief has been running for 4 hours and 40 minutes. 4 hours and 40 minutes. So from 3 p.m., 3 a.m., 3 a.m., you go back 3 hours, that is 12, that is midnight. You go back further 1 hour, that is 11, and you go back 40 minutes. That means 10:20, the thief broke free. This approach that you see right now is very, very simple, even simpler than the last approach. But I am not using relative speed here. I did not rely on the concept relative speed for this. What I am doing is I am depending upon the concept that distance must be same for two people to meet. क्योंकि दोनों सेम जगह से स्टार्ट कर रहे हैं, डिस्टेंस मस्ट बी सेम फॉर पीपल टू मीट. Confirmation on this? Sure. Moving on. Try this. Now, this question sounds a little weird because you have to visualize a vehicle going up a hill or a mountain and a dog coming down and going back at different speeds. This is slightly different than that bird example. In bird example, the forward distance and forward speed was same as backward distance and speed. In this case, when climbing down, the speed is fast, so less time will be required. While climbing up, the speed is slow, more time is required. Please observe. There's a car climbing up a hill at a speed of 45 kmph. A dog sitting at top of the hill spots the car when it is 585 kilometers away. So dog must have some kind of divine vision, and the hill is 585 kilometers long. The car starts running towards the hill. The the car starts running to and starts running. And means dog starts running towards the car at a speed of 40 kmph. As soon as it meets the car, dog turns back towards the top of the hill at a speed of 60 kmph. Dog continues this to and fro motion from top of the hill towards the car and again back to the top of the hill till the car reaches top of the hill. Find the total distance traveled by dog. I could also frame what is the distance traveled by dog downhill, what is the distance traveled by the dog uphill, and so on and so forth. So I wanted to visualize this scenario rather than creating a long uh, hill. I'm using this small slant. Imagine this is total 585 kilometers, 585 kilometers long. There is a car here, and the car is going up at what speed? The car is going up at a speed of 45 kilometers per hour. So when the dog notices this, the dog leaps forward, goes down at a speed of 140 kmph. Let us say dog and car meet here. Now, when the dog goes back up the hill, it goes at a speed of 120 kmph. One thing is clear, because this is the top of the hill and dog will always need to come back to the top of the hill. So it is traveling same distance both ways. Downward distance, upward distance is same. Distance is same. Going down and going up, distance is same. What I notice here is, because distance is same, we know speed and time taken are inverse. What is the speed ratio? 140 ratio 120. This is going down, this is going up. The speed ratio is 7/6. So the time ratio would be 6/7. Going down, if the time is 6 hours or minutes or days, anything, 6. While going up, the time should be 7. Now, can I say dog will keep on traveling, going down, going up, going down, going up, going down, going up, till the car reaches the top. What is the distance? 585. What is the speed of the car? 45. 5 into 9, 5 into 1, 1, 7. And this is 9 into 13. That means for 13 hours, the dog will keep on running. And do you see the addition here also is 13? That means 6 hours, the dog is traveling down. 7 hours, the dog is traveling up at the speed of 140, at the speed of 120. That is 840 plus 840. That is 1680 kilometers have been traveled by the dog total. Please observe how did we approach this problem. We realized again the dog will always need to go back to up. It has to go up back to the same spot. That means distance down and distance up will always be same. We can approach this in one more effective manner. Please observe. We know that the dog has to climb down at a speed of 140 and climb up at a speed of 120, and distance is same. This gives me idea that the average speed can be calculated as twice of a into b upon a plus b. So 2 into 120 upon 140 into 140 upon 260. Never multiply or divide until necessary. You want to cancel a zero, be my guest. You want to cancel this two, that is fine. You still have 120 into 14 upon 13. That is what speed average. Now, do you understand? As long as the vehicle or the car reaches the top, the dog will keep on running at this speed. This is the average speed, up and down, average speed. So how long will it take for the car to go there? We just calculated this a few minutes back. 585 kilometers at a speed of 45. This was 13 hours. So 120 by 14 up upon 13, this is the speed, into time must be distance total. So 12 into 14 is 168.0. That is the distance total. Take your time, copy this down. Once I move away from this, you will not be able to come back to this. Copy this neatly, cleanly in your rough work. Moving on. Let us try one more problem. Then we end the session today. A tiger stands at a point A at a distance of 40 meters from A, stands a hare. The tiger starts chasing the hare and goes in pursuit of the hare at 40 meters away. The tiger takes two leaps of 2 meters against 1 meter long leaps of hare. If the tiger takes two leaps against hare's 3 leaves, then at what distance from A will tiger catch up with the hare? Again, a simple question. There is a lot of word play. No speed has been given to you. No exact time has been given to you. You are being given a comparison that when the tiger leaps, the distance covered is 2 meters. When the hare leaps, distance covered is 1 meter. If the tiger takes 2 leaps against the hare's 3, then at what distance from A will tiger catch up with the hare? You will see me use this kind of language one more time when we are studying uh, escalators. In escalators, very rarely the speed value is given or time value is given. Everything is given in terms of steps or leaps. Escalators. So how do we approach this? How do we approach this? You visualize this. There is a tiger here, and at a distance of 40 meters, there's a hare, a kind of rabbit, some same type of animal. Now, when this tiger jumps, it covers 2 meters in one jump, and this one covers 1 meter. This one is traveling less distance, and this is very important. Listen to this. Understand the significance of this. If the tiger takes 2 leaps against the hare's 3, tiger takes 2 leaps against hare's 3, that basically means in the amount of time this one takes 2 jumps, this one will take 3 jumps. Leap means jump. So time frame pe dhyan do. I do not know whether it is 1 minute, 2 minute, 1 second, 2 seconds. I do not know that. But in the same time, the jumps are 2 and the jumps are 3. One jump is 2 meters long. So in the amount of time t, tiger travels 4 meters. In the amount of time t, the hare travels 3 meters. I don't know what is that time. It is 1 second, half a second, 0.1 second, millisecond. We do not know. But we know that tiger is traveling more. How much more is tiger traveling? The tiger is traveling 1 meter more. Do you see? let us say if the overtake happens here, tiger and hare meet here, distance is d. So hare is traveling d. How much is tiger traveling? Tiger is traveling 40 plus d. So how much more does the tiger need to travel? See, tiger travels 1 meter more in time t when there are 2 meters and 2 jumps. I want tiger to travel 40 meters extra. I want tiger to travel 40 meters extra. So tiger will be traveling 160 meters and hare will be traveling 120 meters. So what is the question? Then at what distance from A will the tiger catch up? Where is tiger? Tiger is at A. So from A tiger is at A. At what distance from A? 160 meters. You can also answer how many leaps did the tiger take? 40 times of 2, 80 leaps. In 80 leaps, tiger will catch up with the hare. It will catch up. पकड़ा नहीं है. They are at the same point. पकड़ने के लिए if you say एक extra leap count किया जाता है. Learn this part. You may not come across a question like this. To pounce, to catch, to hunt. To hunt the hare, the tiger will need one more leap. 80 leaps में उसके बराबर पहुंच गया. Almost same point. In theory, we say if the tiger must catch the hare, there must be one extra leap. Yes, these PDFs are being uploaded. All the lectures we have done so far, quant, LRDI, verbal, all of those have been uploaded on your app. You can access through your login as well, the laptop, desktop login. So tomorrow we will cover 6 to 8 more questions on. अच्छा multiplied by 40 समझ में नहीं आया. See here every time the tiger travels 4 meters, the hare travels 3 meters. So how much more has been traveled by tiger? 1 meter more. How much more does tiger need to travel to catch up? Tiger needs to travel 40 meters more. See, if 1 meter is traveled by hare, tiger has to travel 41 meters to catch up. If 2 meters are traveled by hare, tiger has to travel 42 meters to catch up. So tiger has to travel 40 meters more. Right now, tiger has traveled 1 meter more. Every time tiger travels 4 meters, the hare travels 3 meters. So 1 is always more. I want there to be 40 meters more. I want tiger to travel 40 meters more than the hare. So tiger has to travel total 160 meters. Hare will have to travel 120 meters. The gap is 40 meters. Catch up हो गया. We will use this approach अच्छे से सीख लो in escalators. In escalators, they rarely give the actual amount of time or their actual speeds. Yes, ये बड़ा काम आएगा अपने को आगे. Yeah, done for today. Yeah, good night.